Number 1. Does anyone have any questions on how to find the critical value? Are we okay with that? You guys got 0, -2, and 2? Okay. And so when I said do the sign diagram, we want to test things in between. Guys, here's a helpful strategy. You already factored f prime because that's how you found the critical values, right? Watch what happens when I put in certain values. Watch. What did you pick? Did you pick a really negative number for this first interval? -3? All right. Super negative. Well, look. For something like -3, f prime of -3 is going to be, remember, I don't really care what it equals. I just care about the sign, and there are 3 factors. And if I put -3 in for those, it's going to be negative times negative times negative, which equals what? Negative. So I'm decreasing over here. Oh, you're right. 2 minus -3. Positive. Thank you, Tori. I better be more careful. Let me check those other ones. 2 plus -3. Negative. 4 times -3. All right. So let's correct this. This is going to be positive. And that means the first one is increasing. Sorry about that. Okay, what comes next? If you put in -1, let's see, f prime of -1, I get negative, this time the middle one's positive, 2 and -1, right? And the other one's positive. So I get negative times positive, I get negative. So this part we are decreasing between -2 and 0. And then what happens here, f prime of +1. F prime of +1, they're all positive. So it's positive, so we're increasing. And now if I do something like f prime of 3, I get a positive, and here's where that last one that gave me trouble before is going to be what? Negative. So I get a negative, so we are decreasing over here. Okay? And just for kicks, I sketched a graph on the calculator to save time. Here's my function. Notice when I press graph, I can't see very much. But it is increasing. You know, this is like a W kind of graph upside down, I guess an M, right? If I zoom out a little bit, maybe I could see a little more. Sometimes you have to play with the window a little bit to get it, okay? Okay. -5 and 5. -30 and 30. Let's take a look at that. They have a choice called zoom fit you can do, okay, which also might give you a pretty good curve. Yeah, that worked out nice. Okay, number 2. A trig function. And I don't know how much you know about this, but one thing I'll tell you is, let's take the calculator. If you're going to type it in the calculator, you better know how to type it. And I gave the hint on the board. It's cosine in parentheses so that you can square it, all right? That's what you want to type in the calculator. One other hint is that if you hit zoom trig, choice 7, it'll probably give me a pretty nice window. Hey, what do you notice about this? It does look like a trig function, but it's always non-negative because I'm squaring it, right? But let's do the calculus without the calculator and see what happens. So I get f of x, well, f prime of x is bing 2. Bing cosine x to what power? Bong. What's the derivative of cosine? So I think I would write this as f prime of x equals -2 a lot of people would write it as sine x cosine x. I don't know why we do that, but we do. -2 sine x cosine x. Okay. To find the critical values, I set the derivative equal to 0. Now, how do you get this big ugly thing equal to 0? Well, that happens when the sine of x is 0 or when the cosine of x is 0. Now, where does that happen? Well, more importantly, where does that happen on this interval? Right? Because it happens infinitely many places. But when I go from negative pi over 2 to 3 pi over 2, I know, for instance, that the sine of 0 is 0. And I know that the sine of pi is 0. Okay? And the only place that it's going to happen for the cosine function is when I take the cosine of pi over 2. Okay? That's also 0. I know that the cosine of 3 pi over 2 is 0, but we're not including that. This is an open interval. Same as negative pi over 2. So when I go to do my sine diagram, okay, I guess what I look at is I look at places, like 0, pi over 2, and pi. Okay? And I know I'm going all the way out to 3 pi over 2, and I'm going all the way to negative pi over 2. But now it's just a matter of putting things in that are in between these values. And by the way, this actually isn't too bad, because when you're thinking about 0 and pi over 2, which quadrant am I in? First quadrant. So I claim that when I go to take something like f prime of, let's say, pi over 4, or something in between, I'm going to get negative 2 times a positive times a positive, because in quadrant 1, I know the trig functions, sine and cosine, are both positive. So this is negative. So we are decreasing in this interval. And I think if you work it out, you'll get alternating, decreasing, increasing, decreasing. Kind of like, seems like that's what we've gotten most often so far. Warning. That doesn't always happen. Okay? We'll talk more about that next. Point that I'm trying to make on this group work is the idea of the domain of a function being important. You notice I didn't say anything about the domain of this function, but you guys know what that means, right? The set of all possible x. Okay. I like to say input because sometimes you have a function of t or a function of something else. Input. Okay? So let me ask you this. For this particular problem, what's the domain? Can x be anything you want, or is it restricted? It's restricted, right? What are you not allowed to put in for x, for this function f of x? You can't put in negative numbers. We already said we're going to keep it real in this class, right? So x has to be greater than or equal to 0 is my domain. Which is funny because I think when you guys did your work for the first derivative, didn't you find a critical point of negative 1? Well, that's not a critical value then, okay? Because it's not even in the domain of the function. I'm going to go ahead and show you the work. People tried the product rule, and people also did this, which I would do. You want to simplify it, okay? So take this square root of x and distribute it, and that makes it a little bit faster when it comes to taking the derivative. What's another way to write the square root of x, by the way? X to the 1/2, okay? So then f of x is actually equal to x to the 3/2 power plus 3x to the 1/2 power, okay? Maybe that's my start. And now f prime of x is equal to 3/2 x to the 1/2 power plus 3/2 x to the negative 1/2 power. And maybe while I'm at it, I'll take the second derivative because I know I'm going to need that for this problem. They want me to do a second derivative test. And so f double prime of x would be, well, I guess it would be 3/4 x to the negative 1/2 power minus 3/4 x to the negative 3/2 power, right? Okay. And most of you were able, after a little bit of hints here and there, to do a first derivative test in this problem. I want to kind of jump ahead to how I would work with this second derivative. Okay? So what I would do is I'd like to try to write this as one big fraction. I think that's helpful. Okay? So let's see. We can write it, first of all, maybe as 3/4. And here I guess I have x to the negative 1/2 minus x to the negative 3/2. Right? And so that is 3/4. Maybe I'll make this a little bigger for you. So x to the negative 1/2, how am I going to write that? 1 over square root of x, right? Minus, now I'm going to do this quickly and see if you guys understand it. X square root of x. That was quick, but do you follow it? Because x to what power? Well, if I don't have anything, it's a first power, right? And here we have x to the 1/2 power. So x to the first times x to the 1/2, that's like x to the 1.5 power, which is what 3/2 is. Okay? Guys follow that? If you do, that's outstanding. And then what do I have to do next? I'd like to subtract these fractions, but I can't. I need to find a common denominator. What's the common denominator I want to get? Okay? And so I claim if you take that first fraction, and if you multiply the top and the bottom by an x, you're going to get it. Okay? So let's continue to do some work here. Let's see. F double prime of x equals 3/4 of, well, let's see, I have x minus 1 over x square root of x. Okay? How's that look to you, okay? Did I write it as one big fraction? I guess so. I mean, you might write it this way, too. 3 times x minus 1 over 4x square root of x. Something like that. Okay. And I want to apply the second derivative test, okay, because that's really the focus of this group work. The second derivative test. So now you might say, well, what are some important values that I should put on my number line? Anyone have an idea of something I should put on my number line? Let's put 0. How come, Kim? Yes. 0 would make the second derivative undefined. By the way, remember the domain of the function? What's the smallest thing you're allowed to put into the function anyway? Matter of fact, let me start to draw a graph, because that's part of the exercise, right? Let's draw a graph of this thing. So if I'm going to plot this, the smallest value I put in is x equals 0. What is f of 0? Let's see. F of x was x plus 3. Yeah, because you have to multiply by the square root of x, right? So f of 0 is 0. Okay. And you told me this graph is always increasing. Let me just do something else. Let me do f of 1, just for kicks. I'll get 4 times 1 is 4. So it goes through 1 comma 4. That's all I know so far. I think the next nice point to plug in would be 4. Then you get, what, 14 or something like that? So over there somewhere. Okay. But before I just do that, let's complete the second derivative test. What's the important point besides 0 that I'd want to put on my number line? Yes. Because the second derivative equals 0 when x equals 1. So I'll point out that right at 1, we have f double prime of x equals 0. Right? Okay. So now what do we do next? Tell me what to do. Sure. What would you pick, Tori? Give me something. 1/2 is a great point, right in between there. Okay? So let me compute. When you say plug in, it depends what test I'm doing. I'm doing the second derivative test, right? So let me compute f double prime of 1/2 equals 3 times negative 1/2 over 4 times 1/2 times the square root of 1/2. And again, guys, I don't really care what it equals. All I care about is it, and what would you say? F double prime of 1/2 is negative. So what does that tell me about the function there? Concave, what? Down. Concave down. Okay? We'll try another point. Let's try something like 4. If I compute f double prime of 4, I think you'll agree I get positive. And that tells me over here I am concave up. Now how does that help me sketch the graph? Well, remember up here, I plotted a point, right? I plotted 0, 0, I plotted 1, 4, and then I plotted, I was about to plot 4, comma, isn't it 7 times 2, so it's 14? 4, comma, 14, let's see, 4, 8, 12, 14 is way up by where I wrote my name. Somewhere up there, maybe a little higher. Okay? Now, the reason this helps is because between 0 and 1, we are concave which way? So the graph goes like this in a concave down until we get to that point, and that point is called a point of inflection. And so now, I'm increasing the whole way. Some of you guys said that with the first derivative test. You noticed, hey, we're increasing the whole way. Well, what happens is I'm increasing less and less and less until I get there, and now I'll start increasing more and more and more and more and more, forever. And so that gives you an idea of what the curve looks like without a calculator. Then it's good to take the calculator and confirm that. To save time, I'm saying that you can get this by the quotient rule. Let me just say, when it comes to the second derivative, you don't necessarily need the quotient rule. There's another way to write this now, which saves some time. Do you see what I can do? I can write it as x plus 1 to what power? That's a nice trick to know. Because now it's really easy to find the second derivative. If you do the quotient rule again, it gets like a little nasty, then you have to cancel out some x plus 1. But if you do it this way, what do I get? It's just bing, bing, bong. Negative 2, there's my bing, and then what? To the negative 3, bing, and then bong. What's the bong? The derivative of x plus 1, right? What's the derivative of x plus 1? 1, because it's 1 plus 0, so 1. So that's really nice. You get the second derivative very quickly, and now let's write it as a big fraction. We'll write it as negative 2 over x plus 1 cubed to the third power, right? Hey, by the way, I kind of should do what I did last time. I should say something about this function f of x, and that is, do we know the domain of this function? What would you tell me? Yeah, x is not allowed to be negative 1. So that's good to know. By the way, we covered this already, even though your book is going to cover it in section 3.5. What do we know about this function in terms of what would happen if I were to graph this function at negative 1? Do you know what happens at x equals negative 1 for this function? We have a vertical asymptote, right? We talked about asymptotes already. So, let me sketch that. There is a vertical asymptote at x equals negative 1. By the way, while I'm at it, is there a horizontal asymptote? How do you know? The powers are the same. The leading term has the same power, and the coefficients are 1. So what's the horizontal asymptote? It would be y equals 1, because what we do, remember, is we look at the leading coefficient, 1 and 1. And whatever that fraction is, that's what the horizontal asymptote would be. That's the limit as x goes to infinity. So when I go to sketch graphs without a calculator, the first thing I look for are asymptotes. That's one of the first things I look for. And on Wednesday, the title of the section we're going to cover is Sketching Curves. Okay? And I'm telling you, this is one of the first things you want to do. Look for asymptotes. You also want to take derivatives, which we've done. And then you want to plot easy points. Like, if you were going to plot this function, okay, so maybe I'll plot it in red. So let me just write, f of x is x over x plus 1. Can you give me a point that you know is on that graph and you would plot right away? Sure, put in 0. What do you get for an output? F of 0 is 0, so that's this point. Anything else you might plot? Why'd you do negative 2? Yeah, negative 1 doesn't work, but negative 2 does. Like you said, it's clean. You get negative 2 over negative 1, so what do you get? 2. Negative 2 comma 2 is right there. You guys with me? Let me plot positive 2. Positive 2, what do I get? I get 2/3, right? Or positive 1, what do I get? 1/2. So I can start to see what's happening. It goes to 1/2, it goes to 2/3. Hey, Paul, you're not doing calculus right now, you're doing algebra. And you guys are right. I'm just graphing like I used to in an algebra class. Isn't that correct? But I did draw these asymptotes, and that kind of tells you what's going to happen. If I continue to move to the right, what's going to happen, guys? I get closer and closer to that 1. See that? But I never actually touch it. What happens if I continue to move to the left? Like, let's put in f of, say, negative 1/2. Well, that's ugly. Negative 1/2 over negative 1/2 plus 1. That's negative 1/2 over what? Positive 1/2. And so what's that equal? Yeah, Paul, you're not doing any calculus. I know. But I still think it's good to see that, do you see that this is going to get closer and closer to the green asymptote that I mentioned? So I wouldn't actually need to do all this. I would understand that, oh, it's going to get close to the asymptote. And if you do similar experiments over here, you'll find that this curve kind of does this kind of stuff. So, Paul, why is this on the group work? Well, because we can learn some things. Okay? Now, if we were to do a first derivative test, let me do that over here. By the way, the first derivative is equal to, if I write it as a fraction, what would it be? 1 over x plus 1 squared. Right? I'm going to point something out to you. I claim that f prime of x is always what? Positive. Except for -1 where it's undefined. But remember, -1 is not even part of the function. If it's always positive, what does that tell me about f of x? F of x is always what? Increasing. And you can see that on our graph. I don't care which part you're talking about. As I drive from left to right, I am always increasing. Always increasing. You guys see that? That's kind of neat to see. What about the second derivative test? Well, now it's not quite so clean cut. Right? I mean, I'll have to draw a number line. What's the important point to put on the number line? Yeah, because at -1 we know that the second derivative is undefined. So let me try something like f double prime of 0. So f double prime of 0 would be -2 over 1. It would be negative. But if I do something like f double prime of -2, I get -2 over -1 cubed. What would you say about that, guys? Would you guys agree? Is that positive? Because when you cube a negative, it's still negative. So this is going to be positive. And so what did I learn about the function from this? Well, we are concave up on this side of the asymptote, and we are concave down on that side of the asymptote. There are no points of inflection for this picture. Okay? And that's another reason I knew that the curves would do this kind of behavior. Just go right to the asymptote. Because otherwise there's a point of inflection, and we'll see that in other examples, especially on Wednesday.